All right, today we're going to dive into a pretty slick cybersecurity technique that's all about catching the sneakiest threats out there. It's called Stateful Protocol Analysis, and it's designed to spot attackers who are absolute masters at hiding in plain sight. So here's the big question, right? What do you do when an attacker isn't, smashing down the digital door? What if they've already got a key and they're just acting like they belong? They aren't breaking the obvious rules, and that makes them incredibly difficult to spot with your standard security measures. And that whole challenge brings us right to our first key idea, this whole art of an attacker hiding in plain sight. I mean, think about it. A lot of network security systems are basically like a bouncer with a really simple list. If your name's not down, you're not coming in. Simple. But what happens if the attacker's name is on the list? They can start manipulating the normal back and forth of a network conversation. That's the protocol, without triggering any of those basic alarms. They're just bending the rules of engagement, not breaking them wide open. Okay, so if they're just bending the rules, how in the world do you catch them? Well, it all starts with really getting what we mean by stateful. Yeah, I know, that's the official definition, and it is a total mouthful. But the two most important words in there are protocol state and deviations. See, this isn't about looking at one single action all by itself. It's about understanding the entire conversation, from beginning to end. It knows what's supposed to happen at every single step or state in that conversation. And this is a really important distinction. You might have heard of anomaly-based detection. That type of system learns what's normal for your specific network, and then it flags anything that looks different. Stateful analysis, though, is different. It uses a universal rulebook, like a master blueprint that says, here's how the HTTP protocol is supposed to work, everywhere, period. It's based on the official design. So let's ditch that simple bouncer analogy. A much better way to think about this is like a really smart security guard, one who actually understands context. Right, this guard doesn't just glance at your ID when you walk in. They remember you. They know that you're not allowed in the server room without getting special clearance first. They know that propping open the fire escape is a major no-no. That memory, that understanding of the rules of the building, that is state. It's the ability to track the whole session and know what should, and definitely what shouldn't, be happening at any given moment. Let's actually see how this plays out in the real world. We'll use a pretty basic file transfer protocol, or FTP session, as our example. This breaks it down perfectly. So a user connects, right, but they haven't logged in yet. Their state is unauthenticated. Now, if they immediately try to delete a file, the system knows, whoa, hold on, you can't do that in this state, and it blocks it. That's suspicious. But then, after they provide a good username and password, their state changes to authenticated. Now when they try to delete that very same file, the action is totally valid and it's allowed. See? Same action, different state, completely different outcome. And that right there is the real power of stateful analysis. It's this incredible ability to catch these subtle, context-based deviations. Because it's tracking the whole session, it can spot things that other systems would miss, like weird, illogical command sequences. Maybe someone's just spamming the same command over and over. And because it tracks authentication, it knows exactly which user account is behind any funny business, which, let me tell you, is a huge deal for investigators. It can even apply different rules for a regular user versus, say, a system admin. But my favorite feature has to be what's called the reasonableness check. This is where the system goes beyond just the basic rulebook and applies something kind of like, well, common sense. It asks a really important question. Is this command technically allowed, but also just completely bizarre in this situation? Here is the perfect example. A server might technically be programmed to accept a super long string of text in the username field. But the stateful system, it knows that usernames are usually, short. So it flags a 1,000-character entry as extremely suspicious. Why? Because it's probably an attempt to trigger a buffer overflow or some other kind of attack. It might be allowed by the protocol's code, but it is not reasonable human behavior. But, of course, no security method is a silver bullet. And stateful analysis definitely has some pretty significant blind spots we need to talk about. First off, if an attacker is just using totally valid commands to flat out overwhelm a server, think of a denial of service attack, stateful analysis might miss it completely because no single command is actually breaking the rules. Then there's the problem where the system's perfect model of a protocol doesn't quite match how some vendor actually built it in the real world, and that can lead to a ton of false alarms. Oh, and it has a really tough time with proprietary protocols where the rulebook isn't public. But honestly, the biggest drawback is just the raw cost. All of this tracking and remembering context and analyzing thousands of connections all at once, it takes a massive amount of processing power and memory. As you can see here, compared to just simple packet inspection, the resource overhead is way, way higher. And all of this really just leads us to the bigger picture here, the constant, never-ending arms race that is cybersecurity. This is absolutely not a set it and forget it kind of solution. The moment a software vendor updates their product or the official standards evolve, those underlying protocol models have to be updated too. If your security guard's rulebook is out of date, they're going to start missing things. It takes constant work to keep it effective. So in the end, stateful protocol analysis is a massive leap forward, no question. It teaches our security systems to understand context, not just isolated commands. But it still doesn't really understand intent. And that leaves us with a really crucial question for the future. As the attackers just keep getting smarter and better at blending in, what's the next step for us? How do we build a system that knows not just what you're doing, but why you're doing it?